Hi, and this is a presentation of the link state dynamic routing protocols. The link state dynamic routing protocols is protocols that use the shortest path first algorithm. It's something that was invented and made by Dijkstra. He has made an algorithm about the shortest path. And if we look at the link state routing protocols, we have two different. We have the OSPF and we have the ISIS, which is Intermediate System to Intermediate System Protocol. We will probably, or we will work with only the OSPF protocol, which is an open standard for the link state protocols. When we look at the Dijkstra algorithm, it will calculate the best path by looking at how they are connected and the cost of each link between them. So it's an accumulated cost for which direction will we do. And each link has a cost. And when we're looking at OSPF, it could be, for instance, the bandwidth of the different links that we have. So then it will look at, if I want to reach one of these networks, how do I get there? What is the shortest path? Looking at when we look at the different costs here. So the shortest path to router 1 LAN from router 4 is go to router 3 and then to router 1. Because then we have an accumulated cost of 17. Instead of going directly from router 4 to router 1, which is, if we were using a distance vector, we will have chosen that one because then it will only involve one hop. But since the bandwidth is probably much faster when we go from router 4 to router 3 and then to router 1, then this is the preferred route when we are using link state routing protocols. So the link state routing process is that, of course, here again, the routers know about their own directly connected networks, and then they start sending hello packets to their neighbors and to their neighbors, the one that they are directly connected to. And then they send out these link state packets and tells about their networks. That means that when we start the process of a link state protocol, then there will be a lot of traffic involving that everyone should say hello to each other and everyone should tell each other about their networks. But when everything is started up and when there is no changes, well, then there will be no traffic involved in a link state protocol. So then, of course, if there is a change, we will send out an information, but we will only send the information about what has changed, not the entire network like we do in the distance vector. So it's more efficient to work with, and it will take resources when we start the communication and when we start using OSPF, for instance, but when it's running, it doesn't use the links that much for updates, only if there is a change. So here when we start, well, then they know about their own directly connected networks, and then they will start sending these hello packets to their neighbors, say that I am router 3 and I'm router 4 and so forth. If they stop receiving these hello packets, it's kind of keep alive packet. Then if they stop receiving them, then they will consider their neighbor as being unreachable. So they form these adjacencies to all their neighbors, and then they start getting information about the different networks that are connected to the different routers and on what kind of a network that we have. For instance, a serial point-to-point, or if we have a fast Ethernet and so on. So we will know the different types and we will know the different bandwidths. And we have these link state packages that will exchange information about this. So as I said, when we start up, we have a lot of information sent out because all of them need to tell everyone about how they are configured. And then they build like this. They have this link state database telling us all the different connections that we have and all the different costs. And by using this database, they will build their shortest path tree setup. But then they will know which way will I prefer. What is the fastest? What is the best path to our different networks? And that is the routing protocol. So by doing so, and then, here we have like an entire map of, because we know how far away the different networks are. So of course also here, if there is a change, then we will only get the update about the change. Yeah. So they uses this shortest path algorithm and shortest path tree to find to set up the information in the routing table. The advantages of link state is that it builds the entire topology map. It will have faster convergence. It will also update only when needed, not in periodic updates. The disadvantages is that, of course, it uses more resources in the routers, because creating and implementing the shortest path algorithm, you have to use both the memory and the CPU in the routers. And of course, when you start up, you flood the links. But then again, after a while, it will only send out updates if there is a change. Yeah, protocols that uses the link state is OSPF, and is also. OSPF are in different versions. We have an OSPF version 3 for IP version 6 and OSPF version 2 for IP version 4. Yep, and that's it. Thank you.